EET 114, Chapter 18, Methods of Analysis and Selected Topics. First, we're going to talk about independent versus dependent sources. Independent sources are what we have been dealing with up to this point. It's an example of these four. An independent specifies the magnitude of the source is independent of the network to which it is applied, and that the source displays its terminal characteristics even if completely isolated. So down here you have an example of a dependent or independent DC voltage source. This is an independent AC voltage source. This is an independent DC current source, and this is an independent AC current source. So the next question is, what are dependent sources? Where dependent or controlled sources are ones whose magnitude is determined or controlled by a current or voltage of the system in which they appear. So here's two examples. This is an AC voltage, okay, and it is dependent on this other voltage over here across this resistor. It doesn't necessarily have to be a resistor, it could be any element. This is just an example, and there's a multiplier K1 times that voltage. So whatever this voltage is, let's just say it's 100 volts, and let's say K is 10. So it's 10 times 100, which would be 1,000 volts across this dependent AC dependent voltage source. So this is a voltage dependent voltage source because it's dependent on voltage over here, and it is a voltage source. Likewise, this example is a current dependent current AC source. So, and I know it's AC because it's we're dealing with AC in this chapter, and this is a bold eye, and this is also a bold eye. So you have to find the current through this element, and then multiply it by K2, and then you get the value of the current that's flowing through this source. All right. So you can have four different kinds. You can have a voltage dependent voltage source, a current or a voltage dependent current source. You can have a current dependent voltage source or a current dependent current source. Okay. Now I say this is voltage dependent because it's labeled as a V here. So it depends on whatever that V is across another part of the circuit. Likewise, this I is dependent on another current in the circuit. This is dependent on a voltage. This is dependent on a current. This is a voltage source. This is a current source. So then what they're showing you is if if V was equal to 0, what would you do with this thing? Well, with a voltage source, you're going to short it, and with a current source, you're going to open it. Likewise, if I was 0 on these two guys here, on a voltage source, again, you short it. On a current source, you open it. And then the next part is to convert, again, between when you have a voltage source in series with an impedance, you can convert it to a current source in parallel with the same impedance just by using Ohm's law between them. So if you're given this E and this Z, then you could figure out what this current source is in parallel with the same impedance. And likewise, you can go backwards in the other direction.